In April 2024, Dubai experienced the deadly flood, due to which it results the million of damage in infrastructure and few people got killed. So many video clips and newspaper articles on the flood event went viral on the internet, which motivated me to create a video on this topic. Today I am going to do the rapid flood mapping and analysis using optical imagery such as Landsat and Sentinel 2, and also using the SAR imagery. Such technique might be very helpful during the rapid flood mapping or monitoring application. Let's get started with the video. I hope you will enjoy this. Before starting video, I want to share you one thing. My channel analytics shows that more than 90% of my viewers haven't subscribed to my channel. If you are among those viewers, please subscribe to my channel so that I might get motivated to create more and more interesting tutorial. Also, don't forget to hit the bell icon. So let's get back to the video. First of all, let me talk about location and date. Location wise, it's the north and east part of Abu Dhabi, Dubai, which is in United Arab Emirates, got flooded due to excessive rain on April 16th and April 17th of 2024. And according to several newspaper articles or the research shows that it's the year worth of rain in just 12 hours. That means it's very intense, and it has like intense rainfall event due to which water got collected due to failure in the drainage system, and then it get flooded. And there are several newspaper articles talking about its impact. For example, the first one is like Dubai flight got cancelled, school and offices shut as rain pelts UAE just a week after deadly flood, right? And then desert nation UAE records its most rain event, and also there are few which are talking about like the cause of the rainfall event. It might be the cloud seeding, and then which generate the so intense rainfall and the current drainage management system failed to hold that much of capacity of like water, due to which it got flooded. But to be honest, I'm unsure about like whether the cause might be cloud seeding or not. The cloud seeding is the artificial way of getting rain in the certain portion of the city or the land. And talking about its impact, as of May 5, at least 20 people get killed due to the flooding event, and there is like disturbance in transportation, and also lots of flight got cancelled. And it says that estimated 30 to 50 thousands of vehicles get affected, and also estimated 8,050 million USD worth of infrastructure got damaged, which is very high. And the Copernicus try to like map the flooded region from space using I think Sentinel 2 dataset, and you can see there are so many clouds here, but we can clearly see the flooded region, which is dense here, and maybe this one, right? So these are like the flood imagery from like Copernicus dataset, and these are the few reference. So yeah, which I use in the previous slides. So let me get back to the flood mapping and flood analysis section. So let's start with the Google Earth engine first. Alright, so in order to map the flooded area, I would like to use this code first from UN Spider. Don't worry about this link. I'll provide this link in the video description below. So it's the step-by-step recommended practice for flood mapping using Sentinel-1 SAR dataset in Google Earth Engine, right? So there is like really nice documentation like how to do the things, but don't worry about it. I'm going to discuss about this code anyway in my video. So the first thing is you need the code. So you can click on this link to get the code to like get the flood map. So simply copy this code and then paste it in the Google Earth Engine code editor, or since I already done that before, so here is my code and I already like copy and pasted the same code and then try to change the few chunk of like dates and then the geometry. So first thing first of all, what I did is using this button, this draw a shape button, I created my area of interest, which is like this. So this is my area of interest. So manually by like clicking like the shape, so you can simply like create the polygon. For now I'm going to delete it. So this is my area of interest, right? And as I said before, so this is the recommended practice from UN, United Nations. So it says that they are using Sentinel-1 dataset, and then to run this demo, so we need our own study area, and then we need to select the two images. One is like before flooding event and another one is after flood event, right? So since I already show you in the presentation, the high intense rainfall happened on April 15th and 16th, right? 16th and April 17th. April 16th and 17th is the highest rainfall in Dubai, right? So that's why I selected like before imagery, maybe up to 15. So 2024 for 1 to 2024 for 15. That means we are trying to like select our imagery based on this date. And after flood, since we know that rainfall happened in 16th, that's why I'm selecting the imagery from 16 to 30. And the polarization, of course, we are trying to go with the default one, BS. Of course you can use BB or SV, I think, as well. And then the path direction is descending and ascending. For now I'll just keep the setting same as it is. And then different threshold. So what this value will do is it's to apply it on the different imagery, after flood minus before flood, and then based on that we try to calculate the like flooded region. And this here we are like selecting imagery and then filtering our required image, and then this is like date filter, and this is also about the date. And we like also calculate the flood extent. So here we use our threshold value, I think somewhere here. Okay, threshold value to get our binary map, whether the area is flooded or not. And also later on this code, so I'm not going to like explain all the code line by line. You can read that in this documentation, but here they also did the damage assessment. For example, they also try to calculate the population count, how many population got exposed due to this flood event using this population database from this link. and also they have like agricultural land damage, and then more stuffs. So I'm not going to like explain everything in detail. So for now I'll just simply uncheck this option and then run the code. Okay, by using this code you can see the legend. Our legend is potentially flooded area, and then green is affected cropland, and affected R1 is represented by gray. And yeah, this is the actual metrics so far we got. So yeah, before like explaining this result, so let me share you the images what I selected so far. So for the like before flood event, I'm using the imagery from April 3rd, and then the after flood I'm using the image from 27 of April. So one of the drawback of like using Sentinel-1 imagery is like we might not get the like data what we want. For example, if we get the imagery from 18 or 19, that would be more accurate, but since we don't have data till like 27, so that's why the result might not be that accurate. That means this map will represent the flooded area on 27th of April, not on the 18 or 19. Okay, so if I like zoom into the areas, so you can clearly see that near this this structure here we have a little bit of flooded region, and also like these are the like population density, and its metrics start from 0 to greater than 200. And talking about the result, so this map is the flood status between like 16 to 30, but yeah, actually it's the flood extent on 27, and the estimated flood extent on that date is around 1200 hectare, which might not be accurate. I feel like more than this area might be flooded on like before that. And estimated number of exposure is around 4000. So yeah, that's all about like Sentinel-1 imagery. And yeah, there are basically like two drawback with this method. The first one is we might not get the imagery on exact date what we want for, and then the second one is there are little bit of more variables so which might affect our flood map. For example, polarization, path direction, and threshold value. So these are the variables, right? So for example, if I say VB, then our result will change dramatically. So BH is mostly built for polarization for flood mapping. So yeah, we it's possible we don't like use VB polarization for flooding event is yeah, recommended by UN Spider. So yeah, in VB polarization you can see so many area is like flooded. Yeah, that's the like few drawback with the Sentinel-1, I mean SAR dataset. Okay, now let's get to the like optical dataset. So maybe in the optical one, for example, here I'm using the Landsat 9 dataset, which is 30 meter spatial resolution, and then I simply created the AOI, so on the like a little bit smaller area than before, right? And then I added that to the map, and then I try to filter it cloud less than 10%, and then filter the bound, and then after that I select the few bands to calculate the normalized difference water index, and then I take the median value, and then I selected the required bands, and then I calculate the MNDWI, and then I applied the threshold value of maybe we can apply 0. That means if the value is greater than 0, those are the like flooded, I mean the water body. Otherwise it's just the land, some different infrastructure. Okay, and based on that, so I apply this threshold value, and then I added all these three different things into the map. So if I run this result, so now we are like taking the imagery from 16 to 20, which might be more accurate than before one, right? And then using this one, so this is the like binary map. Of course we can like a little bit, for example, first of all let me like change the visualization pattern of true color, and then maybe I can toggle it off. This is the MNDWI value, and so this is my Landsat map. And if I like slide this, sorry, I need to check this, and then slide this on and off, you can see that it's like clearly distinguishing the like water body and non-water body. For example, let me zoom into the few locations. For example, here if I like change the opacity, I feel like it's doing great job like detecting the water from imagery, right? So that's how also we can like calculate the flooded region. And the thing, one more extra thing you can do is like you can remove the permanent water bodies, for example river and then the sea, from our binary maps to get the like flooded region here. And using similar approach, I can also like do the similar approach on Sentinel-2 dataset as well. And then on the Sentinel-2 also I can try to see the same date, cloud coverage less than maybe 20%, and then yeah, filter the image and then select the required band and then calculate MNDWI and then get the water body. So let's see. Oh, there is no image in this date. Maybe I need to change it to like 30 again. And okay, so this is my map, and it might be a little bit like covered with the cloud. And in case of like cloud coverage, we might not get the like actual water bodies max. Okay, let me toggle this off. Yeah, seems like this is the like cloudy region, right? So maybe I can increase it to 50. I saw the better image on 50% cloud. Yeah, you can simply like play around with these variables to select the like best imagery. And then okay, now if I check the imagery, looks like it has very less cloud, right? So let me zoom into the like same area and then try to see how much good job it's doing. Seems like it has over predicted the water bodies, right? Or yeah, so seems like it has like over predicted the water bodies, right? So in that case you can play with your threshold value. For example, if I say threshold equal to 0.2, then I might get the different result. Okay, sorry, I need to check this option. And then okay, yeah, it's also over predicting, but in case of like real water, you can see this block, so it's clearly like visible, right? This is water, but yeah, our model is also predicting that is a water. And the thing is like, for example, these are the cloud, right? In case of cloud also it's predicting is like water body, but that's not true, right? So maybe this error is happening due to like the little bit of more cloud coverage, or maybe we can change uh, the threshold percentage more, then yeah, we might end up with the little bit less water bodies. Oh, sorry, I feel like I'm doing nothing, so I have to like update this threshold value over here. Instead of 0, I need to pass the threshold. So this time let's try 0.2, and then it has now different map, right? So yeah, I think it's not estimating properly again, so we might need to like change the value to the 0.1, and so try to see the water bodies. So for that, I'll sense the visualization pattern for the true color, and then maybe zoom into the particular some section, and then try to like see the water. Okay, seems like this time it's doing well, better than before with this threshold, but of course it's not perfect, right? So I feel like Landsat 9 was the little bit better version till now, and the like as I said before, so the problem with optical imagery is the cloud, right? So we might not get the best imagery what we want for during the like rainy season, and most of the area might be like covered with the cloud during like rainy season. That's why that's the like drawback of the optical imagery. And also during like selection process, so we might not like get the imagery on exact date. That's also issue with the optical. The other approach to explore the flooded extent is using planet dataset. So in order to get the planet imagery, you need to subscribe to their like pricing plan. And for me, I have educational and research account, and if you want to know like how to create those account, check the video in the link description. And okay, so first thing is here also you need to like select your area of interest. For example, I'm interested in this region, so simply select it by like creating your polygon. And then you also need to like your filter your date. For example, if you are interested from 1 to 30 of the April, then click done. And after that you can easily like compare your map before and after flood. For example, maybe in the after flood event, so I'll put the 21st April image, and then in the before flood event, maybe I can put the 14th April image, right? So these are the full images. And then in the full image, it's very hard to see the flooded region, but let me zoom into the some of the area and then try to compare these. Okay, for example here, so if I swipe this here, so you can see this area is not flooded, this is fully covered with the sand, right? But if I sweep this here, that means in the 21st April it has water, so this area is also like flooded, right? So yeah, these two. And similarly I can like zoom into the other area and then try to like see the flooded area as well. For example, in this particular street, so let's swipe it here and there. So it seems like here there is like not much changes in this street, so that means this street is not flooded, right? So yeah, in a similar way you can simply like compare the images from two dates and then try to see the flooding pattern. So that's an alternative approach, right? So yeah, so that's all about this video. So I hope you enjoyed this video. So if you enjoyed this video, hit the like button and subscribe to my channel. So these are the all methods to do the flood mapping, either using optical dataset or the SAR dataset.